Hi, so in this video we are going to learn how to find the area of different geometric shapes. So here we are going to derive the formula for the area of a rectangle, square, parallelogram, trapezium, triangle, and after that we will also derive formula of the area of a rhombus and a kite. And as you can see, I have already drawn a grid. This is actually a grid of unit squares where each tiny square is of the length 1 unit and of the breadth 1 unit. So this grid will actually guide us and help us to find the length and breadth of the geometric shapes, and it will also help us to find the area of those geometric shapes. If you remember, area of any geometric shape is in square units, right? So that square unit is actually a square of unit dimensions. That means it is actually the square of unit length and unit breadth. So these tiny squares are actually the squares of unit length and unit breadth. So if we can count how many such squares are there inside any geometric shape, we will be able to find area of that geometric shape. Let's start with rectangle. So if I draw a rectangle over here, whose length is actually equal to 10 minus 2, 8 units, and its breadth is equal to 6 minus 2, that is 4 units. So if we want to count the number of squares this rectangle has, what can we do? Yes, we can count the number of squares it has along the length. So this will be a row, and then we can count how many such rows are there in this rectangle, and if we multiply the number of squares in a row to the number of rows inside this, we can get the area of this rectangle. So we have total 1, 2, 3, 4, 5, 6, 7 and 8 squares along the length, and we have total 1, 2, 3 and 4 such rows. So we are actually going to have total 8 multiplied by 4, that is 32 such squares. We can write the area of a rectangle is equal to length multiplied by breadth, because here length tells us the number of unit squares along the length and breadth tells us the number of unit squares along the breadth, and that will also tell us the number of rows which are along the length are there in the rectangle. So this is the formula for the area of the rectangle, and if I make the length and breadth equal to side, then this shape will get converted into a square. The square is actually a special case of rectangle where all its sides are equal, length and breadth are equal. So the area of the square can be written as side multiplied by side, because length is equal to side and breadth is also equal to side. And now let's talk about a parallelogram. So this is a parallelogram where opposite sides are parallel. This side is parallel to this side and they are equal also. And this side is parallel to this side and these two sides are also equal. And in a parallelogram, this side is called base. And then we have height of the parallelogram, which is actually the length of the perpendicular drawn from one vertex of the base to the opposite side of the parallelogram. So from this vertex, if I draw a perpendicular on this parallel side of the parallelogram, this orange line is called the height of the parallelogram. Okay, so how to find the area of this parallelogram? I'm going to cut this parallelogram from here and I'm going to paste it over here. It actually becomes a rectangle of length equal to base and breadth equal to the height of the parallelogram. And now we already know the formula for the area of a rectangle, so we can write the formula for the area of a parallelogram, which actually is base multiplied by height. And now let's try to find the formula for the area of a triangle. Suppose we want to find the area of this triangle, where this is the base of the triangle, and if I draw a perpendicular from the vertex which is exactly opposite to the base, this will be known as the height of the triangle. And how to find the area of this triangle? I'm going to cut this triangle, copy it, and then flip it vertically, flip it horizontally, and join it over here. And it gets converted into a parallelogram. And area of that parallelogram will be equal to two such triangles. So area of this triangle can be written as 1 by 2 the area of the parallelogram. So that can be written as 1 by 2 base into height. Okay, so now you can say whether it will be true for an obtuse angle triangle also. So let me make an obtuse angle triangle over here and let's see. So this is an obtuse angle triangle, and this can also be converted into a parallelogram. So this is the copy of the triangle, and let me flip it vertically and then horizontally, and then if I join it, you get a parallelogram whose area is exactly the double of the area of the triangle. So from here also we can say the area of a triangle is half base multiplied by height. And now let's talk about the area of a trapezium. Trapezium is actually
Welcome to the area of a circle, where we learn the area of a circle. Ready? Start with your circle and measure the radius, which is a line halfway through the center. This radius is 3 meters. So what's the area of this circle? Area of a circle equals pi times radius squared. So what we do with this circle is we realize that pi equals 3.14. The radius in this situation is 3 meters. Radius squared equals 9 meters squared for this circle. So the area of this circle is 3.14 times 9 meters squared. Are you ready to see the answer? Great! The area of this circle is 28.26 meters squared. There you have it, the area of a circle.